Hello students. Now we are going to discuss the concept of joint probability distribution. So in the previous video we discussed some basic definitions about the probability and the probability distribution and the types like discrete random variable, continuous random variable. So those definitions we discussed in the previous videos. Now we take the concept joint probability distribution. So here if x and y, so these capital X and capital Y represents the random variables, okay, and here x and y are two discrete random variable. So discrete random variables are, these are the variables which takes the finite finite values these variables take. So then these random variables are called discrete random variables, okay. Then the joint probability function of x and y means the combinations of the values of these x and y is given by p of capital X equal to xi. So this xi, the values of capital X, this capital X takes the values xi and capital Y takes the values yj, which is also we denote as f of xi comma yj. So this notation represents the probability of, or we say joint probability of x and y, okay, where this probability joint probability function of x and y satisfy the conditions. The first condition is f of xi comma yj greater than or equal to 0, means when we take the joint probabilities of these x and y, so that value must be greater than or equal to 0, okay. This should not be negative. This is a one condition. The second condition is summation I equal to 1 to m and summation j equal to 1 to n f of xi comma yj equal to 1, means when you take the sum of all the probabilities, the sum must be 1. So these conditions are same as a discrete probability function, okay. So these are the two conditions. When these two conditions are satisfied, then we say that it is a joint probability function of x and y, okay. And this f of xi comma yj or p of x comma y or p of x equal to xi comma y equal to yj, so this also we denote as jij. So jij is what? It is a joint probability of discrete random variables x and y, okay. So this is the definition. Next, these the set of values of the functions f of xi comma yj, that is jij, for I equal to 1 to m and j equal to 1 to n, is called joint probability distribution of x and y, okay. And these values are presented in the form of a two-way table called a joint probability table. So when we take the values of x and the values of y, the combinations of x and y, we get the probabilities. So those probabilities we are putting in the table form, so that is called the two-way table. So one side we take the values of x, that is a, here x it is denoted, the values of x are x1 x2 x3 so on xm, and this side values of y y1 y2 y3 so on yn. So this is what denoted xi, where I equal to 1 to m, I equal to 1 to m and j equal to 1 to n, that is y1 to yn. So understand this table because the next two problems are depending on the table. So once you understand, so what are the probabilities we are denoting in the table, and what are the sum. Okay, so when you understand the concept of this table, the next part will be very simple. See, we wrote the values of x and y. First, we take the joint probability of x1 and y1. We take the combination of these two, x1 and y1, and this j11, it is the probability, that is a joint probability of x1 and y1. That is a notation. Next, the joint probability of x1 and y2 is j12. The joint probability of x1 and y3 is j13. Likewise, the joint probability of x1 and yn is j1n. Similarly, we take the combination of other values of x and y, like x2 y1 j21, x2 y2 j22, x2 y3 j23. Likewise, we take the combination of the values of x and y, and these are the joint probabilities of x and y. Okay, the notations, like all the j here, these are the probabilities, joint probabilities of x and y. Next, in this table we have the column. This is the column sum, and this is the um, row. So here, this sum g of y1, it is the sum of j11, j21, j31, so on, jm1. It is a column wise, we take the sum of the joint probabilities. When you take this plus j31 and so on, when you take these sum, and that sum we denoted as g of y1. Similarly, taking the second column, j12 plus j22 plus j32, so on, jm2, these the sum of these values, it is g of y2. Similarly, these sum we denote as a g of y3. So these are the column sum we take. Now we take the row j11 plus j12 plus j13. We take the row wise sum, so on, plus j1n. So this sum we denoted as f of x1. Similarly, second row sum, third row sum, we denoted as f of x1, f of x2, f of x3, so on, f of xm. Okay, now according to the conditions of the joint probability distribution, each probabilities must be greater than or equal to 1, sorry, greater than or equal to 0. Okay, and the second condition is the sum of each probabilities must be 1. Like when you take the row wise sum, and when you add all these, it must be 1. When you take all the column sum, and when you add all these values, so the sum must be 1. When you take the column sum, or when you take the row sum, it must be 1. So this is the second condition. Clear? So this is called joint probability table. And here are the other information about the table, like marginal distribution, marginal probability distribution. So here, as it is already told, f of x1 is j11 plus j12 plus j13 plus so on, j1n. So this is the sum which is denoted by f of x1. Similarly, f of x2, second row, j21 plus j22 plus j23, so on, j2n, that is f of x2. Likewise, f of xm, when you take the sum of all these values. Similarly, when you take the column sum, g of y1, it is defined as j11 plus j21 plus j31 and so on, jm1. Likewise, we take all the sum, and here these f of x1, f of x2, f of so on, f of xm, and g of y1 plus and g of y2 and g of so on g of yn. So these are called the marginal distributions. Okay, then again in these marginal distributions, see, these marginal distributions like f of x1, f of x2, so on f of xm, so these are called marginal distribution or marginal probability distribution of x. F of x1, f of x2, so on f of xm. So these are called the marginal probability distribution of x. And g of y1, g of y2, so on g of yn. So these are the marginal probability distribution of y. Okay, seeing again that table. So in this joint probability table, so these sum f of x1, f of x2, f of x3, so on f of xm. So these are called marginal distribution of x. And these g of y1, g of y2, g of y3, so on g of yn. So these are called marginal distribution of y. Okay, next, and it is also discussed in the table, these sum must be 1, and also the sum of the total all the entries must be 1. Okay, next definition, independent random variables. So these joint probability of x and y, the variables x and y, whether these x and y are dependent or independent. So that how we check, see, the discrete random variables x and y are said to be independent random variables if p of x comma y, that is the joint probability of x and y, so that we can write as the product of probability of x into probability of y, that also we can write as f of xi into g of yj. So this product must be equal to jij in the joint probability table. So in other way we can say that x and y are independent if each entries in the each entry jij in the table, okay, in the table is equal to the product of its marginal entries. Otherwise these x and y are said to be dependent. Okay, so this again I explain with by referring the table. See, when you can say that x and y are independent when we take the product of the marginal distribution, like I take f of x1 into g of y1. Actually in the problem we have numbers in the table, I take f of x1 into g of y1. When you take the product of these numbers, the corresponding entry in the table is j11. Okay, for f of x1 and g of y1, the corresponding entry is j11. And see that when you take the product of these numbers, it must be equal to this number j11. If this condition satisfy, we can say that the variables x and y are independent. If the product of these marginal entries are not equal to the entry in the table, then these are dependent. You can check for any marginal entries, like I take g of y2 and f of x1. F of x1 into g of y2, the corresponding element in the table is j12. G of y2 into f of x1, when you take the product of these two, the corresponding entry in the table is j12. See that this product, when you take the product of these two, we get some value, and that value is equal to j12 or not. By checking this way, we can say that the variables x and y are dependent or independent. Okay, now we consider some simple examples. So whatever so far we discussed, we take the problems on those. The first one is the joint probability of two random variables x and y is given by the following data. Okay, the table is given joint probability of x and y. Now the question is determine the marginal distribution of x and y and also verify that x and y are independent. Okay, first taking this table, again you have to draw the table, right? Now we have to find the marginal distribution. It's a very simple. These are 1 2 1 2 are the values of x, 2 3 4 are the values of y, and these are the corresponding probabilities. Okay, now we add the numbers 0.06, 0.15, 0.09. When you add this, the sum is zero point 0.3. Again adding this row 0.14, 0.35, 0.21, this sum is 0.7. Okay, now we add column 0.06, 0.14 is 0.2, 0.15, 0.35, this sum is 0.5, 0.09, 0.21 and zero 0.09 and 0.21, this sum is 0.3. Now after taking the sum we had to add the marginal distribution. Okay, 0.3 and 0.7 is 1, 0.2, 0.5 and 0.3 is 1. Okay, this sum must be 1. If you are not getting 1 here, then there is a somewhere wrong in the table. This must be 1. Okay, so now as we discussed, this 0.3 and 0.7 are the marginal distribution of x. 0.2, 0.5 and 0.3 are the marginal distribution of y. So that we had to write in a systematic way as marginal distribution of x. So again you have to take a table. X values are 1 2, mention that, and write the marginal distribution of x, that is 0.3 and 0.7 in the table form we had to write. Then marginal distribution of y, the values of y are 2 3 4 and the corresponding marginal distributions of y are 0.2, 0.5 and 0.3. Okay, now we have to verify that these x and y are independent or not, right? So here p of xi comma yj equal to f of xi into g of yj. This is a general one, right? Now I take I equal to 1 and j equal to 1, that is f of x1 and g of y1, right? So this p of x1 y1, that is nothing but it is a j11 equal to f of x1 in the table is 0.3, g of y1 in the table is 0.2, f of x1, f of x2, likewise g of y1, g of y2, right? So f of x1 is 0.3 and g of y1 is 0.2. I am taking I equal to 1 and j equal to 1, and this product is what? 0.06. 0.06. What is a j11 in the table? The corresponding value is here, it is 0.06. So j11 is also 0.06. Okay, so therefore the product of these marginal entries is equal to the entry in the table, right? Then we say that x and y are independent. Okay, this is one simple example. And similarly the second problem, so where the joint probability table is given and the questions are find the probability of p of x plus y greater than 1, and second is marginal distribution of x and y, and also we have to verify that x and y are not independent. For this first one, probability of x plus y is greater than 1, first we have to take this condition x plus y greater than 1 means taking the value of x and taking the value of y. When you add this you must get greater than 1, so all those combinations we have to write first. Okay, that is the event x plus y is greater than 1 occurs only when, means when this condition satisfy, when we take, see, I take x equal to 0 and y equal to 0, x equal to 0 and y equal to 0, take this combination, is this greater than 1? No, 0 plus 0 is not greater than 1, leave this combination. Then you take x equal to 0 and y equal to 1. 0 plus 1. It is also not greater than 1. Leave it. Next combination 1 0. 1 plus 0 is also not greater than 1. Leave this. Then taking 1 and 1. X equal to 1 and y equal to 1. Right? Yes. 1 plus 1, it is a 2 greater than 1. So first combination is 1 1. Then second combination 2 0. It is also greater than 1. Third combination is 2 1. It is also greater than 1. So these are the combinations. So therefore the marginal entries like p of x plus y greater than 1 is what? First, x2 y2 means the marginal, the joint probability is j. The joint probability of x2 y2 is j22. The joint probability of x3 y1, see 1 1. What is 1? This is x1 y1 x1 x2 x3. Okay, this is our x2. So here I denote this is x1 x2 and this is x3, this is y1 y2. So like this we take the combinations. Now 1 1 means 1 is x2 and this one is y2. x2 y2, the joint probability we denote as a j22. Then 2 0, 2 is x3 in the table, 0 is a y1, therefore the joint probability of this we denote as j31. Then 2 1, 2 is x3 in the table, 1 is y2. Okay, then the joint probability of this combination is j32. So j22 value is 0.2, j31 value is 0.1, j32 value is 0. By referring the table we write the values, then this sum is zero point 0.3. This is the 0.3 is the value of probability of x plus y greater than 1. Okay, then determining the marginal distribution is a very simple. Taking the sum we get the marginal distribution of x, and taking the sum of these columns we get the marginal distribution of y. And also we have to verify that these are not independent. So taking f of x1 so taking here also I equal to 1 and j equal to 1, that is f of x1 into g of y1. F of x1 value, that's a marginal distribution, is 0.3 into g of y1 from the table it is 0.6. Okay, and this is what? j11. So j11 in the table is 0.1. Okay, and this product is 0.18. So as these are not equal, so therefore x and y are not independent, so these are dependent. This is the way we verify the random variables. Okay, these are some simple problems on the basic part of the joint probability distribution. Thank you.